Let's look at the first example in section 8.2, geometric series. In example 1, we are looking at the situation of a patient who's taking an anti-inflammatory drug, and they are taking a 10 milligram tablet every 3 hours. When you take a tablet like that, it is known that at the end of 3 hours, 10% of the drug is still in the body. The rest is metabolized, but 10% of the drug is still in the body. We would like to know how much of the drug is going to be in the body after we are taking the first tablet, the second tablet, the third tablet, the fourth tablet, and so on. So in general, we want to find an expression Qn for the amount of the drug present in the body right after the nth tablet has been taken. Okay, let's investigate this question. So we are starting with Q1. We are taking our first tablet, and right after we take the first tablet, 100 milligrams of that tablet of the medication is in our body. So this is the amount after the first tablet. What about 3 hours later? 3 hours later, we are now taking the second tablet. That second tablet, again, is 100 milligrams. The first tablet, though, most of it is gone, but 10% is still in the body, and 10% of 100 is 100 times 0.1. And so we can multiply this out. 100 times 0.1 is 10, so we have a total of 110 milligrams. So that is the amount after the second tablet. Now it's 3 hours later. We are taking our third tablet, and that tablet is 100 milligrams. Tablet number 2 that we took 3 hours ago, we know that 10% is still in the body. So we have 100 times 0.1 from the second tablet. What about the first tablet? Well, every 3 hours, 10% of what was there before is still there. So that first tablet 3 hours ago was 100 times 0.1. Now we multiply that by another 0.1. So really, we are multiplying it by 0.1 squared. So we have 10% of that first tablet is still there. And so when we add those three terms up, we have the amount after 3 tablets. And we can add those up, and when you do that, you have 100, you get 10 from the next one, and you get 1 from the next one. So 100 plus 10 plus 1, that is a total of 111 milligrams. Let's do one more. So after we take the next dose, you see the pattern, imagine, I hope. So the fourth tablet itself is 100 milligrams. The tablet we took 3 hours ago, 10% of that tablet is left. The one that we took 2 doses ago, 100 times 0.1 squared is left. And that very first dose that we took, 100 times 0.1 cubed is left. And adding up all of those terms, we get 111.1. So that is the amount after the fourth tablet. We're not going to do this forever. We are going to say ... what happens now when we take the nth dose? Well, following this pattern, we are starting with 100 plus 100 times 0.1 plus 100 times 0.1 squared plus 100 times 0.1 cubed. We already got that far on our first tablet. Now imagine we keep going. We get many more terms, and for the last term, what do we get? We get 100 times 0.1, and think about for a minute or a few seconds what power we should have. Looking at our powers from before, for Q4 we had 0.1 cubed, for Q3 we had 0.1 squared, for Q2 we really have 0.1 to the first power, so for Qn our last term should be to the n minus first power. There is a nice notation for this type of long sum, sigma notation, summation notation, and the way that works is we're using the Greek letter sigma, and we are writing down all of our terms, 100 times 0.1 raised to the kth power, because that is really the pattern that we are seeing. Every term is 100 times 0.1 to some power. And that power starts for the very first term, we really have 0.1 to the 0th power. And for the very last term, we have 0.1 to the n minus first power. So sigma notation is a nice way to write down in compact form what this long sum looks like.